Hi everyone. Today we're going to be talking about synthesis and decomposition reactions. This is a little bit of a review from last year, but in grade 11 we're going to dive a little bit deeper. So, there are millions of known reactions, so by grouping them into types of reactions, we're able to better predict the products of different reactions. The chemical equation for synthesis is the following pattern. When you have an element react with an element, you will form a compound. So A plus B will make AB. In the previous video, you learned about ionic compounds, which are metal and nonmetal, and you learned about your molecular or covalent compounds, which are two nonmetals. To even better predict the products of synthesis reactions, we can further break down types of synthesis reactions into the following categories. These are the ones we will focus on. There are synthesis reactions of metals with nonmetals, and then specifically we will see synthesis reactions with metal oxide or metallic oxides. So first, let's take a look and do a review of grade 10. Synthesis reactions of metals with nonmetals. These products are the easiest to predict. The process is very similar to figuring out the formula of an ionic compound. We simply use the charges found on the periodic table to predict the products of these reactions. So let's walk through the steps. And here's your general equation. Metal plus nonmetal will produce a binary or ionic compound. Let's do an example with magnesium reacting with oxygen. So what are my reactants? Well, I have magnesium as one, and then I have oxygen as another. Okay? You're going to identify the type of reaction. In our case, it's just a synthesis reaction. Okay? And it is simple metal plus non-metal. Okay? You're going to use the ionic charges of the reactants to predict the formula of the product. So magnesium, if you look at your periodic table, is 2 plus, oxygen is 2 minus. You're going to write the chemical equation and balance it. Okay? So because this is a synthesis reaction, first you write your metal reacting with your nonmetal. Remember though that oxygen is a diatomic. Okay, so by itself, anything that is a diatomic, so you can remember them by Haberfinkel, you can remember them by I bring clay for our new house, or Hofbrinkel. All of these are diatomic molecules, so they will always exist in a pair. Okay, so you always write a little 2 if they're by themselves. Now the magnesium is going to react with the oxygen, and remember this is synthesis, so it's going to produce magnesium oxide. Double check, did I write my formula correct for my product? Well, magnesium is charge of 2 plus, oxygen is charge of 2 minus. You get Mg2O2 when you crisscross your charges, and then you can simplify it to MgO. Okay, that is because we have a common factor of 2. So let's do one more practice, calcium and bromine. Calcium is your metal, so you're going to first write a word equation. So you're going to have calcium. Oops, I'm just going to make sure I'm consistent with the colors. You're going to have calcium reacting with bromine. And then based on your rules for naming ionic compounds, your product is calcium bromide, ending in ide. Okay, now your balanced chemical equation is as follows. Use your periodic table. Calcium will react with bromine. Bromine is one of your diatomic molecules, so you have to write a 2 because it is by itself. Then calcium bromide, CaBr2. Use your crisscross method of charges. You can check it on the side. Now, we might be done, but we might not be done. We always have to check, is it balanced? Well, let's check. On the left-hand side, I have 1 calcium. On the right-hand side, I have 1 calcium. On the left-hand side, I have 2 bromine. On the right-hand side, I have 2 bromine. So we are balanced, okay? And let's just go back here and double check. Did we balance this equation? No, we did not. So let's make sure we do that. We have 1 magnesium on the left and 1 magnesium on the right. However, on the reactant side, we have 2 oxygen. on the product side, we have 1 oxygen. So in order to balance it, you're going to put a 2 on the product side, and you are going to double check. Now I have 2 oxygen on both sides, but now I have 2 magnesium on the product side. So I need to put another coefficient of a 2 in front of magnesium. So remember, these are called coefficients. Those large numbers you write in front of the element or compound, that is a coefficient, okay? The little 2 beside the O2, that is a subscript. And then when we write charges, those are superscripts, so they go up, okay? So coming back to our reactions, let's talk about synthesis reactions involving metal oxides. So when we're talking about metal oxides, sometimes you'll see them referred to as metallic oxides. Okay, there's a couple of different types. The first one is a metal oxide with water. Okay, so synthesis reactions that involve a metal oxide, which is an ionic compound made up of a metal and oxygen. Okay, so you're looking for some kind of metal, let's call it metal X, okay, and oxygen. So oxygen will have a charge of 2, and then whatever the charge of X will be the subscript beside oxygen. So that is the generic formula for your metal oxides. Make sure you're able to identify them. So if I have a metal oxide reacting with water, it will produce a base, okay? And the compound where the anion is OH minus. If you recall your polyatomics, OH minus is hydroxide. Okay, so in general, you're looking for some kind of metallic oxide plus a water. Okay, it will produce a base, right? This is a synthesis reaction, and we'll take a look at how that happens. So similar steps as before, identify the reactants. Our example is sodium oxide reacting with water. So our reactant is sodium oxide, which is N2O, and it's going to react with water, which is H2O. Our type of reaction, right away, we see this is a metallic oxide. We see this is water, so we can confirm this is synthesis. Okay, identify the metal. Our metal in this case is sodium. Okay, the product will be the ionic compound with the metal as the cation and the hydroxide as the anion. Okay, very important to remember. So whatever your metal is, that will be in a compound form with hydroxide. So if I add hydroxide, we get NaOH, and that is our product that we're going to have. Now let's write the chemical equation. So I have Na2O, that's my metallic oxide reacting with water, and it is going to produce NaOH, okay, which is our base. Okay, so now before you're done, always check, is it balanced? Never ever forget to balance. So you'll notice on the left-hand side you have 1 sodium, on the right-hand side 1 sodium, on the left you have 2 hydrogen, on the right you have 1 hydrogen. So what do you need to do? You need to double it. And sorry, you have 2 sodiums on the left and 1 on the right. So there's an imbalance there. For those of you who want to review, how do I set up my tables for balancing? Okay, set up a little table for reactants, set up a little table for products. Write out all the elements you have. Leave oxygen for last when you're balancing. Okay, I'll make a note of that. And balancing. Okay, and then write out how many do I have initially, looking at the subscripts. I have 2 sodium, I have 2 hydrogen, and I actually have 2 oxygens, but they're in 2 different places, right? One is part of the water, one is part of the metallic oxide. On the product side, we have one sodium, one oxygen, and one hydrogen. So we need to multiply by a factor or we add a coefficient. So if I add a coefficient of 2, all of these are multiplied by 2, okay? And now let's double check that we have everything. We have 2 sodiums on the left, 2 on the right, 2 hydrogens on the left, 2 on the right, and 1 oxygen, and 2 oxygens on the product side and 2 on the reactant side. So yes, we are balanced. All right, so let's now talk about metallic oxides with carbon dioxide. Okay, that's the other type that we're going to focus on. So first we talked about metal oxides with water as a synthesis reaction. Now we're going to talk about metal oxides with carbon dioxide. So this reaction is very similar to above. However, the anion, right, the ion that has gained electrons, okay, think onion because onions will make you cry. It's negative. That's the charge of it. In this case is carbonate, CO3 2 minus, okay? That is our anion instead of hydroxide. So for example, the reaction between barium oxide and carbon dioxide, we have barium oxide, which is our metallic oxide, reacting with carbon dioxide to produce barium carbonate, okay? Where did this carbonate come from? Well, 2 oxygens here, 1 oxygen here. There's your 3 oxygens, okay? Where's the carbon from? Right here. So that's where that anion carbonate was formed. And that's why this synthesis reaction is with CO2. Okay, let's try a couple of examples. Let's say I have lithium oxide reacting with, this should say, carbon dioxide. Okay, lithium oxide reacting with carbon dioxide. What kind of synthesis product will we form? Let's try it out. So our word equation is lithium oxide, remember all lowercase, plus carbon dioxide will produce, what will it produce? Well, remember, you need to identify what is the cation in your metallic oxide. So in our case, it's lithium. And then carbonate is our anion, okay, our polyatomic. So let's write out the balanced chemical equation. Lithium oxide, oxygen has a charge of 2 minus, crisscross the charge, lithium has a charge of 1 plus, so Li2O plus CO2 will produce LiCO3. CO3, carbonate has a charge of 2 minus, so it's Li2CO3. So before we're done, we check, have we balanced it yet? No, we have not. Let's check. On the left-hand side, we have 2 lithium, product 2 lithium. That's good. Carbon, we have 1 carbon on the left, 1 carbon on the right. That's good. Now let's check our oxygen. Remember, leave oxygen for last. We have 1, 2, 3 oxygens and on the reactant side and 3 on the product side. So yes, we are balanced. I will leave this next example for you to try on your own. Remember, Haber-Finkel or Hofbrinkel or Ibring-Clay for our new house. So important to remember your diatomic elements, okay? When they're by themselves, it's 2 atoms. They always exist in a pair. Also remember to use a periodic table for charges, okay, when you're writing your formulas. Now, let's talk about decomposition reactions. Decomposition reactions are the opposite or reverse of the synthesis reaction. And we're going to talk about a couple more subcategories in decomposition reactions. So a decomposition reaction is a name of a reaction in which one chemical is split into 2 different products, okay? So these reactions are typically driven by heat or electricity. So if you think of application, if you hear heat or electricity, that should cue that this is a type of decomposition. Okay, so you have a chemical AB that will split into an element or a compound A, an element or a compound B. Okay, last year you simply had compounds splitting into its elements. Now we're going to get a little bit more challenged. So the following are types of decomposition reactions. Remember, these are only here to help you more easily predict the specific products. They're still decomposition reactions. We are just breaking them up into a couple of categories. Decomposition of ionic compounds, decomposition of carbonates, decomposition of chlorates, and decomposition of bases. So let's take a look at each. First, decomposition reaction of ionic compounds. This is what you did last year. So let's try breaking up and decomposing magnesium iodide. First, we're going to identify the reactant. We have magnesium and we have magnesium. I'm rushing ahead to the products. We have magnesium iodide. That is our reactant. What is the type of reaction? It is decomposition. Okay, and it is a simple ionic compound. CMPD is compound. Okay, determine if either the cation or anion exists as a diatomic. So iodine is one of the diatomics, so it should be I2 when you break it up. Okay, write the chemical equation. So I have magnesium iodide decomposing into magnesium metal and iodine. However, iodine is a diatomic, so you have to make sure that you put a 2 beside iodine by itself. Now, before we're done, let's make sure it's balanced. Okay, so we have magnesium on the left, 1 and 1 on the product side, 2 iodine on the left, and 2 iodine on the right. So yes, we are balanced. Okay, now careful with the naming, right? This would be magnesium iodide ending in "ide." That should indicate you have a simple binary ionic compound, whereas this is just iodine, right? Just as you see it on the periodic table. So now let's talk about something a little bit more challenging. Decomposition reactions of carbonates. These reactions typically will happen due to adding heat. The product will always be a metal oxide and carbon dioxide. So we saw this in synthesis. Now we're going to do the reverse. So you're looking for some kind of compound breaking up into a metal oxide, okay, plus carbon dioxide. That's your generic formula, okay? So let's write out the balanced chemical equation example of calcium carbonate. Our reactant is calcium. Oops, I'm going to change my color. Is calcium carbonate. Calcium has a charge of 2 plus, carbonate has a charge of 2 minus. When I crisscross and drop and then also simplify, I get CaCO3. Let's identify the type of reaction. Well, we see this is a metallic oxide. So we know this is decomposition. So it is, that should indicate to us it is breaking up into carbon dioxide and its metal oxide. Okay, so determine the metal oxide formed by looking at the cation, right, the metal, and the oxide. So the cation is going to be calcium. Okay, the oxide, which is oxygen. So we need to pair it with an oxygen. Check our charges. Calcium has a charge of 2 plus. Oxygen has a charge of 2 minus. Crisscross and simplify, you get CaO. Okay, so that is going to be our metallic oxide as one of the products. The other product is carbon dioxide. So now I have calcium carbonate decomposing into our metallic oxide, which in this case is calcium oxide plus carbon dioxide. Okay, so where did I get that calcium oxide from? Remember, when we are forming new products, all that is happening is that the atoms are rearranging. So take a look at this. The calcium on the product side came from the calcium on the reactant side. Okay, one of the oxygens came from here. and went to the products. The other two are here. And then you have your carbon and your carbon. Okay, now before we're done, we have to make sure that we have balanced this reaction. 1 calcium on the left, 1 calcium on the right, 1 carbon on the left, 1 carbon on the right, and 3 oxygens on the left and 3 oxygens on the right, but they're in 2 different products. Remember to count them together when you're trying to make sure it's balanced. So yes, this is balanced. We can move on. Now the next type of decomposition reaction is with chlorates. This reaction typically happens due to adding heat. Okay, so the products will always be a chloride salt and oxygen gas. Now, last year, remember the word salt simply means an ionic compound. So you're looking for an ionic compound that has a formula, some kind of metal plus a chlorine. Okay, so don't let that word salt throw you off. It just means it's an ionic compound with a chlorine, and oxygen gas is the other type, the other product. So if I have some kind of compound, okay, it is going to decompose into a salt or an ionic compound with chlorine plus oxygen gas. Oxygen is a diatomic, so it's O2 always. All right. So let's take a look at an example and apply what we just learned. Write the balanced chemical equation for the reaction which occurs when adding heat to potassium chloride. So potassium chlorate is KClO3. Chlorate has a charge of -1. Potassium K has a charge of +1. So when we crisscross it, we get KClO3. Identify the type of reaction. Well, right away, the ClO3, we have a chlorate. That should indicate we have to do decomposition. And you should remember that it's going to decompose into our oxygen and into our ionic compound with chlorine or our chloride salt. Determine the salt formed by looking at the cation and the chloride. So what is the cation in this case? We have potassium and the chlorine. Double check your charges. Chlorine has a charge of -1, potassium has a charge of +1, so it is KCl in our case. Okay, now write the chemical equation. We have our reactant KClO3 decomposing into our chloride salt KCl plus, remember, you have an oxygen gas as well. Okay, so I want you now to pause this video and really look on the reactant side and the product side. Where did these atoms rearrange to? Okay, now before we finish, let's make sure it's balanced. We have 1 potassium, we're good, 1 chlorine, and we have 3 oxygens here and 2 here. So we have to do something about that. We have to balance it. So I'm going to put a 3/2 to balance it with a fraction. If you're not comfortable balancing with fractions yet, then you simply would just double the entire reaction to make sure it is balanced, okay? So both are valid options. Eventually, you're going to learn to just do your fractions when balancing, only beside oxygen, okay? Otherwise, you usually would not have fractions in grade 11, usually just around oxygen. Again, you can just double the full reaction if you're not comfortable with them yet. All right, so double check it's balanced. 2 potassium on the left, 2 on the right, 2 chlorine on the left, 2 on the right, 3 times 2, so we have 6 oxygen on the product side, and we have 6 oxygen on the reactant side, so it is balanced. All right, let's continue to our next type of reaction. Sorry, not next reaction, but next decomposition reaction type. This is decomposition reaction of bases. Many reactions that occur as synthesis reactions will also occur in reverse as decomposition. Therefore, a base will decompose into metallic oxide and water. So some kind of base, right? So you know that a base will either have a hydroxide or a carbonate. That's how you identify your base. And it will decompose into a metal oxide. Okay, so a metal with an oxygen plus water. So let's try this one out. CaOH2. That is calcium hydroxide. Okay, it is going to decompose into a metal oxide. So identify the cation. In our case, it's calcium. And it's an oxide. So calcium oxide plus water. Now let's balance our chemical equation. First, let's write out the equation. We have calcium, let me type, hang on. Calcium hydroxide decomposes into calcium oxide. Check your charges. Calcium 2 plus, oxygen 2 minus. Simplify, gets you CaO plus 8 water. Okay, let's double check. Is it balanced? 1 calcium on the left, 1 calcium on the right, 2 hydrogens on the left, 2 hydrogens on the right, and 2 oxygens on the left, right? 2 times the oxygen, and 1, 2 oxygens on the right, even though they're in different places. So yes, this equation is balanced. Now you're going to do some decomposition practice. And I want you to make sure that you're checking your answers when you're done. You can find all the solutions posted in our OneNote under 1.03, or you can also, for now, find it in our sequence of learning. Eventually, we're just going to move to using OneNote for checking our answers. Thanks so much. Come to class with questions. If you missed today's class, come to Extra Help if you're finding this really challenging. And I will see you all next class.